Welcome to GW Integrative Medicine, the podcast about disease prevention and health promotion from the Office of Integrative Medicine and Health at the George Washington University School of Medicine and Health Sciences.
I'm Dr. Lee Frame, Program Director of the Integrative Medicine Program here at GW.
And I'm Janet Rodriguez, the office's Administrative Director.
Today we're going to talk about nutrition and the gut microbiome with Scott Jackson, PhD, leader of the recently created Complex Microbial Systems Group at the National Institute of Standards and Technology.
Welcome to GW Integrative Medicine, Dr. Jackson.
Thank you, Janet, and thank you, Lee. Thank you for having me. I'm looking forward to the discussion.
And thank you for joining us. We really appreciate it. We know your time is very valuable. So Scott, to start off, I was hoping you would tell us a little bit about NIST, because I'm not sure that everyone is familiar with NIST.
You are right. A lot of people don't know NIST, and I wasn't familiar with NIST until I started working here. NIST is the National Institute of Standards and Technology. We are a non-regulatory federal government agency in the Department of Commerce. Our headquarters is in Gaithersburg, Maryland, about 20 miles north of D.C. We're one of the oldest technical institutes in the federal government, dating back to about 1901. About 5,000 scientists and engineers and support staff work here. And I just want to point out, usually when people hear Department of Commerce and Technical Institute, there's a disconnect there. Why does the Department of Commerce need a technical institute? And the reason is it goes with our mission. And the mission is to promote U.S. innovation and industrial competitiveness by advancing measurement science, standards, and technology. So we see industry as our stakeholder. We help develop industry standards and new technologies to boost commerce in this country.
And your new group, the Complex Microbial Systems Group, is part of that. And what exactly does your group do?
So we recognize that microbes are an important part of the bioeconomy. Everything from they influence everything from our atmosphere to our agricultural processes to our own health, as we're going to discuss today. And there are huge commercial, industrial ramifications to that. So my group is specifically identifying measurement needs, impediments within this new burgeoning industry of microbiome, and trying to help facilitate and fast forward the commercialization of some of these basic research findings that we've been seeing over the last 10 years.
Great. Thanks so much for that introduction. So now everyone knows why you're here. We're asking you about the gut microbiome. And I know that a lot of people have heard a lot about the gut microbiome. It's been linked to the diabetes. It's been linked to autism, anxiety, obesity. We've seen that it may affect how patients respond to chemotherapy or other medicines. And it makes you wonder, how can the gut microbiome have so many roles?
Yeah, that's a great point. You know, this was something that has been underappreciated and understudied for forever. So the bacteria that live in us and on us affect us in many ways. And I can just give you four main bullet points. They affect us immunologically, metabolically, neurologically, and hormonally. And, these four pathways really affect a lot of various parts of our health and disease, the disparate disease states that you mentioned, everything from Parkinson's to cancer to diabetes. So the bacteria that live in us and on us, also known as the human microbiome, play major roles in our immunological pathways, metabolic pathways, neurological pathways, and hormonal pathways. And collectively, these major mechanistic pathways will influence ultimately our mental state, mental health conditions, as well as autoimmune diseases and everything from cancer to diabetes. Because the human microbiome has been an underappreciated and understudied target for new therapeutic interventions and new diagnostics, we've just begun to see a new industry pop up to begin leveraging and taking advantage of this new therapeutic and diagnostic target, the human microbiome. These new biotech companies and pharma companies are developing the next generation of drugs. And, I affectionately refer to them as bugs as drugs, so bacteria as drugs. In some cases, it may be as simple as a pill containing a concoction of bacteria that you take to treat your particular disposition, whether it's a C. diff or maybe it's obesity and diabetes. do want to point out, this is somewhat of a rant I do on my soapbox when I talk about this, but these new bugs as drugs, these new modalities of therapeutics that we're going to be seeing coming out in the coming years, these aren't your traditional probiotics that you get over the counter at your local drugstore. Rather, these are seen as drugs in the eyes of the FDA. And the main difference being that probiotics, according to the FDA, are dietary supplements that are regulated, and I use the word regulated very lightly here, by the Center for Food Safety. So they're sort of regulated as foods. Probiotics are regulated as foods. And there are absolutely no efficacy claims associated with your traditional probiotics. So they're not allowed to write on the label that these cure C. diff or cure depression, because there's no clinical trials that have been conducted to really demonstrate those types of claims. Contrast that with drugs, according to the FDA's definition. Here, you have claims of safety and efficacy based on robust clinical trials, your traditional cohort studies, double-blind, etc. So these new bugs as drugs that we're going to be seeing coming through the FDA's approval processes, hopefully in the next year or two, will be, an entirely new modality of therapeutic intervention that I believe could possibly transform the way we treat patients and the way healthcare is conducted in general.
Well, that's wonderful. That's very exciting. Thanks for sharing that with us, Scott. So that gets me thinking about therapeutic interventions and how we're trying to correct the human gut microbiome. And makes me, of course, with my background in nutrition, think about the diet. What effect does the diet have on our gut microbiome? And you imagine that a large proportion of the bacteria that are in that microbiome actually got into our guts through the food that we eat. Is that the case?
Yeah, absolutely. It certainly seems logical that the things you put in your mouth end up in your gut, including the bacteria that's covered on the produce that you eat, and the probiotics are the yogurts and other fermented foods that you eat. Certainly the case. That's not to say that exclusively the bacteria that live in your gut came there through the food you eat. There are certainly other environmental factors that contribute to your gut microbes. You're kissing your partner or having a dog. These have been shown to also influence your gut repertoire. But having said that, you mentioned what the quote unquote correct human gut microbiome looks like. That's something we still don't know yet. We can't point to any one person and say that's correct and this other person isn't correct. And this is mainly because everyone, including cohorts of healthy people, all have vastly different ecosystems living in their gut. And these people are all quote unquote healthy. So it's very difficult to point at any one microbiome ecosystem and say that this is right and others are wrong. So, this goes back to, performing clinical trials or epidemiological studies where you have, disease cohorts versus healthy, and you're trying to find trends, biomarkers that are indicators of disease predisposition or a disease itself. So, but certainly, not only the bacteria that are introduced to our gut via the food we eat, but also the food we eat is the fuel for the bacteria. So it's sort of a vicious cycle. The bacteria feed off of the foods that we eat and therefore propagate themselves in a sort of selective way based on what their metabolic properties are.
Now, Scott, as a layperson, I'm the one that's going to get on Google and look around and what's this gut microbiome thing about? And so one of the things I saw had something about you can improve your gut microbiome in a day. Is that true or no?
So I think any healthcare professional will tell you diet and exercise is the most important thing you can do to increase your health. And certainly diet and exercise has been shown to improve your gut health. Now, this goes back to what is a healthy gut. And right now, really the metric that we have to measure gut health is diversity. The more diverse bacteria you have living in your gut, the quote unquote healthier that you are, or the healthier that your gut is. So can you diversify? I think by increasing the healthiness of your gut in a day, to me, that means can you diversify the bacteria that live in your gut in a day? And yes, you can take a probiotic capsule that has 10 different strains of bacteria that are known to be probiotics in the traditional probiotic sense, and now you just increase the diversity of your gut microbiome by 10 strains. So,
but that's only transient, correct?
Absolutely.
That's not going to be like a permanent change.
Absolutely.
So I think maybe Janet's wondering, like, what do you have to do to permanently change your gut microbiome?
That's a great question. And the gut microbiome is both dynamic and stable. And I know those are contradictory words, but if you measure a person's gut microbiome on a daily or hourly basis, you will see large fluctuations in the bacteria that are present in their relative abundance. But if you measure a person over terms of years and sort of, average across a long temporal range, you'll see that a person's gut microbiome is rather stable. For example, when someone gets a regimen of antibiotics for strep throat, for example, it completely just dilapidates your gut microbes because all of those bugs are susceptible to that antibiotic, right? And that's transient in that once you go off the antibiotic, your gut microbes or your gut microbiome will restore itself to largely what it looked like prior to those antibiotics. So you sort of have this dichotomy of dynamics versus robustness and stability. So, if you eat fruit and yogurt for breakfast, and then you eat a salad for lunch, and then you eat a steak and baked potato for dinner, all three of these meals are going to dramatically, but temporarily change the ecosystem living in your gut.
That's fascinating. So one of the things I'm hearing you mention is that this is sort of a personalized experience, that each person has their own microbiome. And as you know, here in our integrative medicine world, we try to focus on precision medicine and personalized treatment. So what I'm hearing from you is that we probably need to look at personalized treatment for these patients, and that could be in the terms of their nutrition, but possibly also in the medications that we give them and how their bugs will respond to those.
Yes, agreed. As I mentioned, everyone's gut microbiome is vastly different. So, one of the and indeed, to echo what you said, Lee, this is indeed a prime area of personalized medicine, precision medicine, where different people will respond differently to different therapeutic regimens. And, one example that comes to mind, and this really reflects Janet's previous question about changing your gut microbiome. Some of these new microbial therapeutic interventions, that is, new strains of bacteria that are introduced to your gut microbiome in a therapeutic intervention way, if you monitor the prevalence of those newly introduced bacteria in the guts of the patients who receive them, some of the patients will retain those new strains and just hold on to them. That is, they will colonize the gut in a stable way for the foreseeable future. Whereas others, within a day or two, that bacterial strain will show up and then disappear. So in many ways, because we're dealing with cells here, the term that's often used in industry is engraftment. So if you think about a tissue transplant, you think about engraftments and whether the tissue takes hold or not. And that's much in the same way that people are thinking about these microbiome therapeutic interventions. Do they engraft? And another way of thinking about that is through pharmacokinetics and pharmacodynamics. Just as you would monitor, the lifetime of aspirin in your blood, et cetera, before it's metabolized or excreted. You have to think about microbiology and ecosystems in the same way that people have been thinking about traditional pharmaceuticals for the last 50, 60 years. And it's really causing us to twist our minds and think about things in a completely different way.
So when these studies are being done, these clinical trials, and say it's a pharmaceutical company or it's a company that's trying to create one of these new bugs as drugs products, are they taking into account all the different effects that everything around you can have on your gut microbiome? I mean, it seems like that might be overwhelming for them. Maybe they just look at a few things that are important. What is the approach that they use?
You bring up a good point. In the clinical trials that are conducted, of course, these are overseen by the FDA, of course, and they are conducted in much the same scrutiny and stringency as clinical trial for any new drug. But what is overlooked and underappreciated here is that perhaps more so than any other type of drug modality, a gut microbiome drug is going to be heavily influenced by your diet. And I believe, and I've heard this from people in the industry, that they do not take into account the diet or nutrition of the patients in the clinical trials with regard to their response. So just like any clinical trial, you're going to have some responders and non-responders. And it certainly seems reasonable that the response or not response may be mediated by your diet and nutritional state. And for the most part, these metrics are not being considered in a lot of the clinical trials. And you all know this better than I do. If you ask them why they don't, they just say it's too hard to get reliable diet information from the volunteers, participants, that people just historically are unable to track what they eat, even if you give them apps and journals and notebooks and things like this. So it is often overlooked and disregarded.
Yeah, I agree. I think that's what the response would be. And as a nutritionist and scientist, I have to say that there's some truth to that, but that's not entirely true. And I think if you have someone who is trained to do dietary recalls and other nutrition methods, you can absolutely get at the gist of what someone's diet looks like. It might not be exactly what they're eating every day, but it's a pretty good idea of what their diet looks like. I also think technology has made that a lot easier. You brought up there are apps, and being able to put what you eat in an app for a week makes it a lot easier than having to write it down in a journal that you have to carry around with you. So I do think that's something that they could add. And I hope that they would consider that.
Yes, agreed.
Okay, so that brings to mind to me, one of the most important parts of nutrition in terms of the microbiome is prebiotics, or the fibers that the bugs feed off of. And that makes me wonder if have someone who has a high fiber diet and their bugs are being fed well versus someone who has a low fiber diet, isn't it going to be a dramatically different response in their gut microbiome?
Yes, absolutely. A person's diet with respect to fiber is certainly a major factor in shaping the gut microbiome. So one just has to do a quick review of the literature to see that the perhaps best mechanistic understanding of how our gut influences our health is through the production of short-chain fatty acids that are direct metabolic byproducts from the bacteria in your gut eating your dietary fiber. So these short-chain fatty acids like butyrate and acetate and propionate, these are modulators in our guts. For example, they're known to be anti-inflammatory, so they can be used to treat or reduce the symptoms from autoimmune disorders like Crohn's disease or celiac. Another great example is that butyrate happens to be the energy source for the colonic cells that live in your gut. So the production of these short-chain fatty acids via fiber fermentation seems to be a very important key to diet and gut health.
Excellent. Yeah, thank you for that explanation. I've definitely been hearing a lot about fiber personally. I was actually at a workshop on special nutritional requirements at the National Academy of Medicine a couple of months ago, and there was a lot of discussion about fiber and how it's not considered a nutrient under the current definitions of what a nutrient is. And that's how nutritionists are taught to think about nutrition. But fiber is very important. And so there was a lot of back and forth about, should we be changing the definition of what a nutrient is if fiber is this important to health and it's important to the production of these short chain fatty acids, which are kind of like a nutrient. Where do we draw that line? There was definitely no consensus in the room. And I imagine if you brought it out to an even broader community, there'd be even less consensus, but it's at least something worth thinking about.
It certainly is. And I was at a meeting recently in New York, and someone brought that same bit of news to the room, that the FDA does not consider fiber to be a nutrient, and that it's sort of seen as a dietary supplement, I guess. But I think as we better understand the influence of our gut on health and disease and the mechanistic effects behind the short chain fatty acids, even more so than our very cursory understanding right now, perhaps in the future, the FDA will have to reconsider those definitions.
Yes. And fiber is very important, but as a nutritionist, I often have to bring up there's a lot more to the diet than fiber. And I would really love to see the research to expand out, because you're right. When you do a quick lit search, you see fiber, and fiber is wonderful, but there's a lot more in the diet. Personally, I would really be interested in seeing how malnutrition and micronutrients are included in that. It seems like a logical next step. That there we go. That is a nutrient. How do these nutrients affect the gut microbiome? There's a little bit of research out there on that, but what's come out has been less rigorous. And I think we alluded to this earlier in the fact that controlling the diet and looking at what's in the diet is much more difficult than some of these other clinical trials. And if we could just administer a fiber supplement, that's relatively easy to fix or to monitor, whereas trying to monitor the whole diet in terms of a micronutrient profile is a lot more complicated.
Yes, agreed. It'll be interesting to see how this field of research evolves over the coming years, decades, because just to echo what you said, it's all about fiber and short chain fatty acids. And while that's wonderful, I'm sure it's very important, there's got to be a lot more to it than that. And I believe we're just beginning to scratch the surface with what is probably the low-hanging fruit, the fiber short chain fatty acid connection.
Yeah, so speaking to the role of micronutrients in the gut microbiome, the European Society of Endocrinology just came out with an article that I tweeted about, I think a couple of days ago, about it was at their annual meeting. They were just talking about how low levels of vitamin D are related to belly fat in patients with obesity, and how that is likely due to the microbiome and the effect of vitamin D on the microbiome, which, if you know anything about me, you know I love vitamin D, and it's really important for the immune system. It's an immunomodulatory hormone, so it makes perfect sense that it would be really important in the gut microbiome, and something that we could explore. But I would love to read more about that article, because I don't know how they were able to tie down so definitively this one micronutrient and the effect of diet, and also exclude all the other elements of diet that could potentially confound that relationship.
Yes, that sounds very interesting, and it reminds me of this idea that we learned early on in our training as scientists about correlation versus causation. And a lot of what we see in the literature these days are correlations that we see, a certain gut microbiome profile is associated with a certain health condition or disease condition. But we don't know mechanistically cause and effect, The perfect example is obesity, and it's been shown that people who are obese have a different gut microbiome profile than lean people, and it's a chicken and egg problem. Did their alternative lifestyle that led to their obesity change their microbiome, or did they have a different microbiome originally that caused them to absorb more energy from their food and therefore become obese? So getting down to the root of the mechanistic regions behind these correlations we're seeing is something that's very difficult to do right now, but is going to be ultimately very necessary as this field progresses.
Yes, that is very true. I was actually, we were just talking the other day about Emran Mayer. who is a gut-brain connection expert, and he decided he wanted to comment on that big New York Times article, the germs that love diet soda, because, as you say, the science is kind of difficult, and the media likes to take the flashy headline, and I can't blame them. They want to get the news out there, and it's exciting, but we have to backtrack and think about the problems with doing this research. And Dr. Mayer pointed out that, first of all, humans are not rodents. This study was done in rodents, and the translation of science from rodents to humans has been abysmal, actually. It's much worse than you would think that it is. It's less than 50% of findings that have translated directly from rodents to humans. So just because something is shown in rodents, we can't say, oh, that's going to work in humans. It's definitely promising and we can get excited about it, but we can't say, all right, diet soda in mice, gut microbiome is going to be the same as in humans.
Yes, absolutely. That's something that the field, the industry often expresses frustration in, is that there aren't good animal models to study how the gut microbiome influences human health. Mouse is about the best we can do, but just to echo what you said, we're not mice. And secondly, the gut microbiome, it is a vast ecosystem. Hundreds or maybe around 1,000 different species of bacteria. 10 to the 14th cells live in our gut. And, this is ecology with a clinical twist to it. And never before in medical history have you had an ecological problem that influences our health so impactfully.
Absolutely. And then, of course, there's the whole movement to get away from animals, in part because the translation has not been so great. And I know you are either working on or work with a group that are trying to do a model community.
That's right. So how do we test a microbiome to see if it's good or bad or do anything? So one is that you can put that microbiome into a human and see how they respond, but that's very difficult to do ethically, especially when we don't know the outcome to be safe. Secondly, you can use animal models, but we've just said animals like mice don't respond as humans do, so they're not a good surrogate. And the third approach is in vitro devices. So my group at NIST has a lot of microfluidic expertise. We can actually engineer devices that we call microenvironments that allow us to control the localized environment around a microbial community. And of course, we can tweak that local chemical environment to possibly look like the inside of a colon. At least that's the hope, that's the idea that we're aiming for. So we have postdocs and principal investigators here right now who are working on the very challenging problem of assembling ecosystems of bacteria in vitro, one strain at a time. So we go out and we buy 10, 20 different strains of bacteria, and we begin mixing them in various ratios, pairs, 1-on-1 and then 2-on-1, etc. And we try to build an artificial ecosystem that mimics the human gut in that it's robust and it's stable and it's reproducible. And, some might call that a model organism or a model system for studying the gut microbiome. And, we see that as very important. And at NIST, it falls directly in line with our mission space in that we're trying to improve confidence in measurements, measurement assurance, and develop new measurements. And, developing these new in vitro devices that allow us to study microbial ecosystems in a manufactured device, but one that mimics an in vivo environment, I think could be hugely powerful to advancing this field.
Oh, that sounds absolutely fantastic. I feel like that's the type of environment we need to do a lot of this nutrition testing, at least to get started with, because that way we can really isolate one element and see what happens when, okay, we change the vitamin D levels or the vitamin C levels or whatever nutrient you want to look at. And then we could start adding them together and see that effect and then reproduce that maybe in humans.
Yes.
Once we have a better idea of the mechanisms behind it.
Yes, so important. Again, going back to the clinical trials where you have microbial therapeutic interventions. In some cases, these drugs, these therapies, they're concoctions of 10, 20, 30 different bacteria. And the importance of each of those strains, I mean, it could entirely be a crapshoot in terms of what you're adding. And if a therapy doesn't work, if a concoction of 20 different strains that you're using therapeutically, if it doesn't have a strong effect in your cohort study, maybe it's just because you left out one strain, and we just don't know that. We just don't understand that. So yes, we definitely need to put our ecologist hat on and sort of back up and enter that realm of ecology and ask, what does a stable ecosystem look like? And what are the underlying principles of stable ecosystems? And then we can begin to look at their metabolic output and hormonal influences and neurological influences.
Well, thank you so much, Scott. That's all the time we have for today.
Thank you for having me. I really enjoyed the discussion, and it's an exciting time that we live in, and it's going to be fascinating to watch this field evolve over the coming decade.
You're listening to the GW Integrative Medicine Podcast with GW's Office of Integrative Medicine and Health.
This is Dr. Lee Frame
and Janet Rodriguez. Thanks for listening.